In this lesson, we will explore Project 6, which covers geological structures and how to read geological maps. Geological structures are primarily categorized into 4 types: horizontal structures, inclined structures, folded structures, and faulted structures. Let's start by familiarizing ourselves with the first top: horizontal and inclined structures. In an area, the exposed layers of rock are generally flat or nearly flat, and these are referred to as horizontal rock layers or horizontal structures, also known as horizontal structure. Sedimentary rocks are primarily deposited in nearly horizontal layers, and due to the influence of tectonic movements, horizontal rock layers are typically found in regions where structural movements have had minimal impact or where there has been extensive, uniform uplift or subsidence. Horizontal structures exhibit several characteristics. Different colors represent different rock layers, and we can observe that the geological boundaries and contour lines are parallel or coincident. On a topographic map, the height difference between 2 rock layer boundaries indicates the thickness of the rock layer. Older rock layers are exposed in lower terrain, while newer layers are found in higher areas. The width of a rock layer's exposure at the surface is called the outcrop width, which depends on the thickness of the rock layer and the slope of the ground. The thicker the rock layer, the wider the outcrop. And when the layer thickness is the same, a gentler ground slope results in a wider outcrop. Table mountains and square mountains are typical examples of horizontal structures, such as Table Mountain in Cape Town, South Africa, known as God's Table. Mount Roraima is a group of flat-topped mountains formed on high ground, boasting the world's highest waterfall, Angel Falls. The famous animated movie Up even took some of its scenery from this location. Over time, horizontal structures subjected to wind erosion can form castle-like mountains, also known as Yardong wind-eroded landforms. The tower-like and columnar landforms in Zhangjiajie are also typical examples of horizontal structures. Rock layers that were originally horizontal can be tilted by tectonic movements, creating an angle between the rock layer and the horizontal plane, which is known as an inclined structure. Inclined structures are usually the result of horizontal compression from tectonic movements, causing the rock layers to bend and exhibit a tilt in certain areas. One of the most beautiful Danxia landforms in China is the Zhangme Danxia landform, where it's clearly visible that the rock layers are at an angle to the horizontal plane. The 3 main elements of an inclined structure are strike, dip, and dip angle. The strike is the azimuth of the line where the rock layer intersects the horizontal plane, which is the line of. Since the strike line is a straight line, it has 2 azimuths that differ by 180 degrees. The dip is the azimuth of the projection CD on the horizontal plane of the inclined line C. Drawn down the layer from the strike line refers to the azimuth angle. The dip has only 1 azimuth, and it is perpendicular to the strike. Thus, the strike equals the dip plus or minus 90 degrees. The dip angle is the acute angle alpha between the rock layer and the horizontal plane in a certain range. Rock layers with consistent dip direction and dip angle are called monoclinal layers. A monoclinal layer with a dip angle greater than 35 degrees is called a hogback, while one with a dip angle less than 35 degrees is called a cuesta. We can use a geological compass to measure the elements of a rock layer's occurrence. Let's first look at the main components of the compass box. The circular structure at the top is called the circular bubble. The black pointer on one side is the dip indicator. The black and white pointer is the magnetic needle. The cylindrical structure in the middle is the long tube bubble, and the semicircular dial at the bottom is the dip dial, which reads from 0 to 90 degrees. The outermost ring of scales is the horizontal azimuth dial. So, how do we use the geological compass to determine the 3 elements of a rock layer's occurrence? First, we place the long side of the compass flat against the layer Adjust it until the circular bubble is centered. And the reading on the scale from either the north or south needle gives us the strike of the rock layer. As mentioned earlier, the rock layer strike has two azimuths that differ by 180 degrees. To measure the dip direction, we align the short side of the compass with the strike line, point the north end of the compass towards the direction of the rock layer's tilt, adjust it to level, and center the circular bubble. The reading from the north needle, the white magnetic needle, gives us the dip direction. To measure the dip angle, we place the long side of the compass vertically and tightly against the tilt line. Rotate the inclinator on the back of the compass to center the long tube bubble. And the reading from the dip indicator gives us the dip angle. There are two methods to represent the occurrence of rock layers: azimuth method and quadrant method. What is an azimuth? It is the angle measured clockwise from true north to the target direction, ranging from 0 degrees to 360 degrees. As shown in the diagram, the azimuth angle of the true north direction is 0 degrees. The east direction is 90 degrees. The south direction is 180 degrees. And the west direction is 270 degrees. The azimuth angle method only requires recording the dip and dip angle of the rock layer. For example, 135 degrees angle 30 degree represents a dip direction of 135 degrees and a dip angle of 30 degrees. Next, I will demonstrate the drawing process of the azimuth angle method. First, turn 135 degrees clockwise from the true north direction, which is the dip. Since the strike equals dip plus or minus 90 degrees, the strike can be determined, and then mark the dip angle at the dip position. The second method is the quadrant angle method, which requires recording the strike, dip angle, and dip quadrant at the same time. What is a dip quadrant? We divide the entire plane into 4 quadrants: the southeast quadrant, northeast quadrant, northwest quadrant, and southwest quadrant. For example, N45 degree angle 30 degree SE represents a strike of 45 degrees north of east, a dip angle of 30 degrees, and the rock layer dips towards the SE quadrant, which is the southeast quadrant. Next, I will demonstrate the drawing process of the quadrant angle method. First, draw the strike as 45 degrees north of east. Extend it in both directions. Since the dip is perpendicular to the strike, the dip can point to the NW quadrant or the SE quadrant, and the problem statement has already clarified that. The rock layer dips towards the SE quadrant, thus determining the dip, and then mark the dip angle at the dip position. To complete it, when the angle between the rock layer and the horizontal plane is nearly or equal to 90 degrees, it is called a vertical structure, and its outcrop width is equal to the thickness of the rock layer. Through this lesson, we have learned about the characteristics of horizontal structures and the 3 major elements of inclined structures. In the next lesson, we will study another type of geological structure: folded structures.